Example 2. Find the Thevenin equivalent circuit between the terminals A and B. As you can see below, there is both a current source and a voltage source. So they will both have to be removed when calculating the Thevenin resistance. So step 1, remove the load resistor. As you can see, the load resistor has already been removed, and it creates an open circuit between the terminals A and B. Step 2, we have to remove both the voltage source and the current source. So what we will do is replace this voltage source with a short circuit and replace this current source with an open circuit. Once we have done that, you can see that if I redraw this circuit for simplification, R1 and R2 are in series, and then they are in parallel with R3 in terms of the terminal A and B. So to calculate the Thevenin resistance, I would add R1 and R2. In this case, it's 12 ohms. And then RTH, the Thevenin resistance, will be the parallel addition of 12 ohms and 4 ohms. So this is equal to 3 ohms. Once that has been calculated, you can then put back in your voltage source and your current source. So I will just draw these back in. As you can see, we're going to have to use nodal analysis to calculate the Thevenin voltage at these points. The point down here, its voltage will be 0 because of the ground down here. So the voltage down here will be 0. So we have two nodes in this circuit. I'll use red. We have V1 and we have V2. So we're going to have to calculate what V1 and V2 using nodal analysis. So we'll look at node 1 first. So node 1, which is V1 in this case. So because this is positive and negative, you'll have the current I1 going in this direction. The current here is going up, so therefore this current going through the R2 resistor is going out and be called I2, and this current will be called I3. So for node 1, you have I1 going in to this node. You also have 2 amps going into this node, and then you have I2 leaving this node, and that is equal to 0. Using nodal analysis, we know that it's the 12 volts minus V1 over the resistor here, plus 2, and then this I2 will be equal to V1 minus V2 over this 6 ohm resistor. Take note that this minus becomes a positive if taken out of the brackets. This simplifies to negative V1 over 3 plus V2 over 6 equals a negative 4. For node 2, which is V2, as you can see above, we'll have I2 entering the node and I3 exiting the node. This will be equal to 0. So we have I2 minus I3 equals 0. As we can see above, we had I2 equal to V1 minus V2 over 6, and I3 will be equal to V2 minus 0 because it's 0 on this line as it's ground over the 4 ohm resistor. So this will be equal to V2 over 4, which is 0. This simplifies to V1 over 6 minus 5 V2 over 12 equals 0. And to calculate the voltage V1 and V2, you use Cramer's rule to calculate this. Once using Cramer's rule, you will be able to find that V1 is equal to 15 volts and V2 is equal to 6 volts. We would like to know what V2 is, because as the 4 ohm resistor is in parallel with the open circuit at A and B, it means that the voltage drop across R3 will be the same as the voltage drop across the open circuit. Therefore, the voltage would be V2 minus the ground, which is 0. So therefore, VTH equals V2. So therefore, the Thevenin voltage is equal to 6 volts. We can then redraw our circuit with your power source and a series resistor with the load resistance. So we have 6 volts, and we calculated the total ohms to be 3 ohms. And this is your Thevenin equivalent circuit. Thank you.